Hello everyone, welcome back to Ansarkari. So, taking up the next set of questions, which will be about pipes and cisterns. So, let's start. So, firstly, we see the formula. Formula says that if the statement is an inlet can completely fill the empty tank in X hours. So, what would be the part of the tank filled in 1 hour? So, to calculate that, we simply have to do the reciprocal of X. So, that would be 1 of X or 1 by X. So, this would be the part of the tank. So, 1 by X part of the tank would be filled up in 1 hour. So this is regarding if it is completely filled. Now, if there's a statement which says that if an outlet can empty the full tank, so it is about being empty or getting the tank is getting emptied, and it takes 11, oh sorry, Y hours to completely empty the tank. So the part of the tank that would be emptied in 1 hour would be again reciprocal of Y, that would be 1 upon Y. So on the basis of this, we have this question. A pipe can fill a tank in 5 hours. So how much part of the tank is filled in 1 hour would be 1 by 5 parts. And next is pipe can empty a cistern in 40 minutes. So it is given in minutes. So firstly, we have to convert minutes into hours. So simply 40 divided by 60 would be 2 by 3 hours. So if find the time in which 3 by 4 part of the cistern would be emptied. So through this, we can calculate the number of parts getting emptied in 1 hour would be 3 by 2 parts. It will be simply reciprocal of 2 by 3. So that would be 3 by 2 parts getting emptied in 1 hour. Now it is asking us how much time will it take for 3 by 4 part of the cistern to get emptied. So this would be simply through the unitary method would be 30 minutes. Now another formula is if both inlet and outlet they are open. So net part of the tank that will be filled in 1 hour would be given by 1 upon X minus 1 upon Y. So 1 upon X is regarding the time that the inlet or it is regarding the inlet and outlet is the rate of getting emptied. So when we subtract that, we get the net thing. So question is a tap can fill a cistern in 8 hours. So this is X, 8 is X, and another can empty it in 16 hours. So Y would be 16. So both the taps, they are open simultaneously. So find the time to fill the cistern. So simply it would be this formula, direct application. So it will fill the cistern in 16 hours. Now, third formula is there are two pipes A and B. They can fill a cistern in X and Y hours. So there are two pipes. So they are working. While working alone, these are the figures. Like only pipe A is open, so it can fill the entire tank in X hours. And similarly for the pipe B. So if both the pipes they are open together, then we have to calculate the time taken to fill or either to empty the cistern given on the basis of what is the question. So the formula would be this X into Y upon X plus Y. So this formula you might have seen even in case of the work done types of questions that we were solving. So this formula also gives us a value of, for example, exactly the same formula that time taken by both the workers to complete the work together if they're working together. So here also it is regarding if both the pipes are open together and they're filling the tank. So how much time will they take to completely fill up the tank? So the question is two pipes A and B can fill a cistern in 20 and 30 minutes. So what would be the total time for both of them to fill it together? Would be direct application of this formula. It will take 12 minutes together. Fourth formula is there are three pipes A, B, and C. They can fill a cistern in X, Y, and Z hours respectively while working alone. So if all the three pipes open together, time taken to fill the cistern would be this. So this is also a repeated formula again from time and work. So this is a question now here it is the language is slightly different given from what we have seen here in case of the formula is the two pipes A and B, they are separately filling the cistern in 8 and 12 hours. So third pipe is emptying the tank. It is not filling, it is emptying. So we have to be very particular about the language of the question and also the units, whether it is given in hours or it is in minutes. So in what time will the cistern be full if all the pipes are open together? So here, this part would be having the subtraction sign and not addition because it is emptying here. Third pipe is emptying. So it will take 4.88 hours to fill the tank completely. Now here, this is very like minute thing here in this formula that two pipes A and B can fill a cistern in X hours and Y hours respectively. They're working alone. So there is also an outlet which is C. But if all the three pipes are open together, the tank is full in ZR. So this figure is also given. Third pipe, which is an outlet that is C, and total time is also given to us, that is ZRs to completely fill the tank if all the three pipes are working together. So the time taken by C to empty that full tank would be like, it would take how many hours to completely empty the tank? So in that case, it would be this formula. So we just have to remember that it is X into Y that will be having a minus or subtraction sign ahead it. So exactly same is the question. You can go through it and we'll have the total time in minutes because here it is given in the form of minutes, like 30 minutes and 60 minutes. And exhaust tab is C. All the tabs are open at the same time. Cistern will be full in 45 minutes. This is Z. And what time can exhaust tab C empty the cistern when it is full? So once the tank is completely full, then we have to calculate how much total time will it take to completely empty the tank. Next formula is that a tank, it takes X hours to be filled by a pipe. So total time, but due to a leak, it is getting filled in Y hours. So it would be definitely Y minus X because one is filling the tank and one is leakage. So it would be subtracting. So the amount of time it is taking when we see that leak is emptying the tank simultaneously. So this is a formula and exactly similar is a question like pipe can fill a tank in 12 hours. Due to leakage at the bottom, it is filled in 24 hours. So if the tank is full now, how much time will the leak take to empty this tank? So X into Y minus X, that is 24 minus 12, would take 24 hours to empty the tank. So a cistern, it has a leak which can empty it in X hours. So it is talking about the leakage. So it is emptying the tank or the cistern in X hours. Pipe which admits 5 liters of the water per hour into the cistern that is turned on. And now cistern is emptied in Z hours. So now we have to calculate the capacity of the cistern, that is the volume. So it would be in liters. So X into Y into Z upon Z minus X. So Z is cistern is getting emptied in Z hours and X is it is because of one pipe or because of the leakage, the time it is taking to empty the tank is given by X hours. So we have to be very particular about what figure would be applied where in the formula because there are a lot of number of figures given in the question. So capacity would be given. So inlet pipe fills at this 4 into 60 liters per hour because it is given to us here. So we just have to calculate putting the values in the formula. Then one pipe fills. So one fill pipe A is there and it is K times faster than the other fill pipe, which is B. So it is the efficiency of the pipe. Now, one statement is if B, it can fill a cistern in X hours, then the time in which the cistern will be full if both the fill pipes they are open together. So it would be X upon K plus 1. And another statement is if A, it can fill a cistern in Y hours, then the time in which the cistern will be full if both the fill pipes are open together is given by this. So it is K upon K plus 1 into Y hours. So these are the two formulas on the basis of if we have a question which is talking about the efficiency of the two pipes. So here we have one sample question. So one fill pipe A, it is 10 times faster than the second fill pipe, which is B. So value of K would be 10. Now, if B, it can fill a cistern in 55 minutes. So then find the time when the cistern will be full if both fill pipes, they are open together. So firstly, converting minutes into hours. So we have to simply divide the minutes with 60 because 1 hour has 60 minutes. Now, time taken to fill it would be again the simple formula of this one, and it will take 5 minutes. Then if one fill pipe A K times faster and it takes X minutes less time than the other fill pipe B. So you can just take a note that here the language is different compared to the previous formula that we have just covered. So there are three statements now. So three formulas on the basis of this statement. So the time taken to fill a cistern if both the pipes are open together would be given by this formula. If A will fill the cistern, so it is talking about individually A fill pipe and B fill pipe. So B will fill the cistern in these many minutes using this formula. A question states that one fill pipe A, it is 5 times faster than the second fill pipe B. So the value of K would be 5. It takes 32 minutes less. So you can see exactly the same language as it is stated here. So it takes 32 minutes less than the fill pipe B, which is the second pipe. And when will the cistern be full? If both the fill pipes, they are working together, they have been opened together. So X is 32 minutes, K is 5. We just have to put the value in this formula, which is stated over here. So we just have to be we have to rightly identify which formula would be used. Otherwise, obviously, calculations will go wrong. So it would be 10 minutes if both the pipes are working together. So these are all different types of the formulas which can be made on the basis of questions related to pipes and cisterns. And we have very minimal chances of such types of questions being asked, but we don't have any previous question on the basis of this theme. So we have covered all the possible formulas for this topic. And thank you so much for joining us on Ansarkari. Stay tuned for further detailed videos on CSAT.